Hello, everyone, and welcome to today's SANS webcast. In the cloud, we don't need roads. My name is Carol Auth of SANS. Today's featured speaker is Kyle Dickinson, SANS instructor and course author. He will be moderating today's webcast. If during the webcast you have any questions for Kyle, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to turn the webcast over to Kyle.
Thank you very much, Carol. I appreciate it. So as Carol mentioned, I'm Kyle Dickinson, and I'm one of the SANS instructors and course authors for the Cloud Security curriculum. And here's just a couple little tidbits of information about myself. I'm a blue teamer at heart. That's where I drive my passion from, and that's where I try to bring that passion of incident response and threat hunting into the cloud. And when I started this cloud journey about 5 years ago, I realized that there was a lot of fundamental pieces that incident responders and threat hunters should understand. And this is where we're going to be bringing some course material from Sec 488, which is our Cloud Security Essentials class, into today's presentation. And so this is how today's going to go. We're going to do a level set of the different types of cloud services and the delivery models. We'll talk about AWS. We'll talk about Azure. We'll talk about strategies that can be kind of dispersed despite what service provider you're using. And then typically we'll have a Q&A at the end, but what I'm going to go ahead and do is just open up for questions during the presentation. So this is a bit more of an interactive type engagement, because I understand that we're all sitting at home, and waiting until the end to ask your question can sometimes be painstaking. So I want to remove that out of the equation and just open it up for questions as we go along, all right? So we're in this together. Let's go ahead and have some fun. So one of the first things I like to call out when we talk about cloud services is, one, how does responsibility change? Because we're entering a partnership with a cloud service provider. And when we enter this partnership, it depends on the delivery model of the cloud service that we're adopting that will determine the type of responsibility that us as a consumer has and the service provider as the provider will have. And you can see here, we have a sliding scale from on-premise where the responsibility was 100% on us. But then as we move over to infrastructure as a service, you start seeing some of these responsibilities shift over to the service provider, such as physical security, host infrastructure, and network controls. But you'll notice that there's somewhat of a blend there, because there are things that as the consumer we will be responsible for, and we'll call those out throughout the rest of the presentation. When we move to PaaS, or platform as a service, that's where the service provider is going to start doing some more of the lifting for us, and then landing at software as a service, where the supplier is going to be primarily responsible for the majority of it. And let's go ahead and talk about the different types of services that we'll see in these different delivery models. So infrastructure as a service, by definition, the advantages are you're going to be paying as you go, so paying for what you use. And that's one of the core characteristics of cloud computing is metered service. So if you're using a virtual machine for 3 hours a day, that's what you're going to get charged for at a high level. You can scale up and scale down. So the elasticity of services that we adopt when it comes to compute resources, we can easily scale up, or what they call right size. So if we have a virtual machine that's provisioned with too many resources and we only see that it's using about 50%, we can do what they call right sizing. And so we're not, just wasting funds and saving money. Now, a couple of the other things to call out when it comes to infrastructure as a service is this is where a lot of cloud journeys begin. This is where your lift and shift really comes into play. So you're going to be taking your on-premise virtual machines, moving into the cloud. You're most likely using infrastructure as a service until you start maturing in cloud service providers, and then refactoring your applications to use services such as PaaS. Now, a couple of vendor-specific examples of infrastructure as a service. For AWS, we have the Elastic Cloud Compute, which is EC2, and VPC, which allows us to create our own private network within a public cloud environment. We also have services like Elastic Block Store. So those are going to be the persistent storage devices that are mounted to our virtual machines. And the benefit of using these virtual machines is we can leverage a base image provided by the provider. There's also some models that allow us to bring our own license. So if you have an existing agreement, we could bring our own license if we wish as well. And then we can configure and deploy our applications as we did on premise. Moving to Azure, very like services where we have Azure virtual machines and Azure virtual networks and disk storage, where again, we have a compute service that we can leverage, place it into our own virtual network that we control. And when we move to VPC or VNet, we have the ability to scope these subnets that are being used. And so if we're looking to do a large lift and shift, but you don't want to do the unnecessary re-IPing of things, ideally, we would be able to reflect this as we would in our on-premise environment. But that all depends on how we do the lift and shift journey. But we do have customization when it comes to our networking, when it comes to the subnets and the CIDR ranges that we have. Now, moving even more with when it comes to the cloud service provider doing more of the lifting for us, we have platform as a service. And think of platform as a service where the service provider is now going to be managing that underlying compute resource for you. And so your builders can start building instead of having to worry about the administration of the underlying application. And examples that we have here of platform as a service is AWS Elastic Beanstalk, which allows us to easily deploy a web application by providing the code and specifying what kind of platform we have. Another AWS example we have is their RDS service, where they have managed SQL Server, MySQL, Postgres, and other database services. So you don't have to worry about that underlying administration. You just can consume that capability right off the bat. Now with Azure, very similar to Beanstalk, we have the Azure App Service, where we can deploy an application and Azure is maintaining that underlying compute. So this allows us to limit the barrier of adoption to cloud services and rapidly innovate when we start using a service provider to begin managing our resources, therefore reducing possibly technical debt, administrative overhead, or the amount of resources dedicated to running and maintaining an application. Now, SaaS, or software as a service, is the very far end of the delivery models. And this is where about 90% of the responsibility is going to be on the software or the service provider. So when it comes to software as a service, things that we should consider is, what does the software development lifecycle look like? Are they instilling best practices and security along their development lifecycle? What are their SLAs? Because we do not have the ability to administer the underlying infrastructure when it comes to software as a service. And that's because software as a service is going to be your web applications, very similar to Office 365. The majority of us are probably using Office 365 in some way, shape, or form, or maybe some sort of chat application like Discord or Slack. These are software as a services where we do not have to worry about scaling up and down our infrastructure or making sure it's geographically redundant. This is all on the service provider. And as I mentioned, Office 365 is a pretty common and easy one to connect with when it comes to a software as a service provider. And they have integrated applications. And we'll notice that when we start consuming SaaS services, these providers are going to be giving us some sort of API so that we can also then begin integrating other applications to the provider as well. So we can create custom add-ons or build upon the existing platform to tailor to our use cases or business requirements. Now, other SaaS providers, I kind of spoiled it, but we have Slack, Salesforce, Box, ServiceNow. So when it comes to the adoption of these SaaS platforms, I would say they're becoming pretty popular, especially when it comes to office management applications, because managing some sort of email server on premise is a large effort and can take quite a bit of resources. Along with any other services that you may think of that you're using on premise, that you wish you could just say, you know what, I want to hand my data to the service provider and let them deal with all of the intricacies of how the sausage is made. I just want to consume the ability to eat the sausage. So let's talk about AWS specifically, and then we'll move to Azure, and then strategies that are agnostic to service providers. So with AWS, we have a few ways to actually get logs from the platform. And when it comes to these logs, it's not going to be okay, we just have one logging stream from Cloudtrail, so we now have total visibility. That is a common misconception that I have seen. So how do we address total visibility? So we have Cloudtrail, CloudWatch, VPC Flow Logs, traffic mirroring, Kinesis Firehose, and the CloudWatch Log Agent. Of these, I'd like to start at Cloudtrail. So Cloudtrail is the who, what, where, when, and how when it comes to administrative actions in our AWS account. And by default, the AWS console will retain the activity for 90 days. But if we want to extend that further and enhance the functionality, we can configure what they call a Cloudtrail Trail. And this is the configuration where we can send these logs to a S3 bucket, which is a object level store, or we can send it to CloudWatch, which is another way we can consume logs, and CloudWatch is a service itself where we can create metrics and alarms if we maybe don't have a logging analytic tool or a SIM in place. It also allows us to enable logging for KMS, which is the key management service, S3 actions, and Lambda. And so other services will seamlessly plug into Cloudtrail, assuming that that service is doing logging to Cloudtrail. And so what's important about enabling KMS logging is this gives us visibility on who's decrypting, who's using what key to decrypt, who's encrypting information with what key. Now, when it comes to Cloudtrail logging, something I like to always focus on, and I wish I started considering this early on in my cloud adoption phase, was how do we address at scale? Because where your organization may be just starting, or you're already fairly mature in the cloud, you may have noticed that there was a jump from maybe 5 accounts, 10 accounts to potentially 50 or 80. Most of the organizations that I've worked with, they're not just going to be using 1 or 2 accounts. And so we want to strategize how we're going to scale our logging strategy so we can, one, have visibility of administrative actions as we scale, and we start reducing security as being a barrier of adoption. And so one thing I like to advocate is centralizing Cloudtrail logs to a security-focused AWS account. So this can be an account that's created just for your security team, for them to leverage for incident response, threat hunting, or for audit logging. And so the way this looks like in practice, and this is actually a really well documented and supported way to log Cloudtrail logs. Visually, this is what it looks like. So you have your AWS account for maybe the finance team, or maybe a completely other subsidiary that you have, and you're configuring the trail to leverage a S3 bucket within the security account. Within that S3 bucket, you can configure an event trigger to where whenever there's an object placed in the S3 bucket, we can initiate a call to what they call the simple queue service. And a lot of the popular logging tools support what they call an SQS-based S3 input. So now what we effectively just did was whenever a new logging event gets sent over to our S3 bucket, our logging tool or SIM is consuming that instead of constantly pulling the S3 API. What's also good about this method, from what I've witnessed, is that if your ingestion for some reason were to fail, say your logging tool was going through an upgrade or your SIM became unavailable, which we never want to think about because that could be a bad thing, the SQS queue can queue up those messages for us. And depending on how it's configured, the time to live for those messages could be a couple days. So as we're doing maintenance on our logging tool, we have these messages queuing up. Now, this is one of those things that you want to trust and verify that this is how it's going to act should you have an outage or interruption with your logging tools. What's also nice about this is depending on how you're creating new accounts, you can configure all new accounts to point to an S3 bucket based by your business units or a single S3 bucket. So as new accounts are created and new accounts are removed, the security team doesn't have to necessarily create a new input on your logging tool for every single new account or remove inputs as accounts get removed. So this is an example of how we can start thinking about addressing these problems at a scale. Other ways that the service providers give us the ability to ensure that we're doing our due diligence in making sure that running infrastructure is being updated and maintained. So AWS offers the System Manager Patch Manager, and this allows us to manage patching to our Windows servers. So if this was your responsibility for your on-premise environment and you don't have the functionality or ability to lift and shift that method for whatever reason, here's how a service provider is providing that natively out of the box with their service offerings. Now, a common question I get is, well, how do we get network visibility to our environment? And traffic mirroring is relatively new. I want to say about 2 years old now. That's available for AWS Nitro instances, which is AWS's home-built hypervisor that extends additional functionality, such as traffic mirroring. And what this allows us to do is create a session and filter for an individual EC2 instance, and then set a target to where the copy of this traffic should be going. Now, what's great about this is a lot of different vendors are creating virtual appliances. So if you had an existing network intelligence tool, they may have a virtual appliance out there that they can be used as a target when it comes to traffic mirroring. And if you're familiar with looking at full PCAPs, this is where we would be getting those full PCAPs, is through traffic mirroring. Vpc Flow Logs are similar to TCP dump, where we have the source destination bytes transferred port protocol, but it's not giving us necessarily the full PCAP data where you might want if you're doing a investigation, or you may have a requirement that you're looking at something, or maybe even troubleshooting an application that's pretty complex. So VPC Flow Logs are a great way to obtain visibility for an entire VPC, where traffic mirroring is per EC2 instance. So they both have value when you bring them into your environment for visibility. Now, if you need to have just, where's your traffic going, and what are the ports that are being leveraged VPC Flow Logs can give us that insight for operational intelligence or for developers to understand, how much is coming in and out of our VPC or our application. Now, VPC Flow Logs can be sent to CloudWatch, or now they can be sent to S3. So if, again, you want to have a centralized logging strategy, we can do that. And the way that we're able to do this is all of these logs include the account ID. So if you're worried about, having all of your logs get jumbled up and providing some sort of confusing information, the account ID is included in the log, so you're able to sort those out when you're doing your queries. Now, if you have a requirement to do some sort of security assessment, either be it just an internal requirement or obligation to your customers, because you may be moving an application that serves customers, you're able to do a security assessment on AWS on the permitted services, but there are prohibited activities. So there are rules of engagement that you need to follow. And on AWS's website, there's a kind of, again, rules of engagement that I would recommend before doing any sort of security assessment. Just review it because it may get updated. It may not be one of those static documents that is the same thing for the last 2 years. So we want to make sure that if we are doing a security assessment, we're following the acceptable use policy and the terms of service. And if you ever have a shadow of a doubt of what you're doing is in a gray area, you can always submit a security assessment request describing the activities. And that would be one thing that I would do. I always like to ask for permission instead of forgiveness, because I certainly wouldn't want to be the person responsible for violating our agreement that we have with a service provider in my enterprise. I would think that would be a resume generating event. Now, other ways to do some sort of security assessments with out-of-the-box tools from our service provider, a tool called Trusted Advisor. Now, there is a premium version of this that unlocks a bunch of other additional checks, but Trusted Advisor isn't just a security-focused tool. It also lets us know, is there opportunity for cost optimization, performance? So do we have EC2 instances that are running at 90% CPU utilization for 5 days out of the week? Is that an opportunity to right size our instance and add some more resources so it's not so strained? And what's also nice is that this can be ran on demand or periodically. So if you don't want to necessarily have to go to every single account, because again, we want to think about at scale, we could send these to our security operation groups, or maybe an operations group that distributes the different domains that Trusted Advisor is reviewing based on the interested parties. So again, another great example of how service providers are providing these tools to us so we can adopt the cloud services in a safe and secure way. Now, when it comes to Azure, Azure has multiple logging platforms, or planes, I should say. And so data plane logs are going to be your logs that you're going to find within the resource. So these could be your Windows event logs. If you've ever troubleshot an application on a Windows virtual machine, you've probably used these before, like the application logs, system and security logs. Those are what we call data plane logs. Processed events are going to be those events that an Azure service has kind of done correlation for us to produce a message, an event, or an alert. And then control management logs, also known as Azure activity logs. These are going to be the who, what, where, when, and how, similar to Cloudtrail. So Kyle started a virtual machine. Mark deleted Kyle's virtual machine on this date. But something to call out when it comes to these control plane logs, such as Cloudtrail and activity logs, is these are great sources to do long tail analysis for our threat hunters. So You may have heard of the impossible login where Kyle may be logged in California, but then Kyle logs into our AWS or Azure consoles from New York, and there's concurrent sessions. That's the impossible travel or the Superman travel, where that might be a potential credential compromise that would be an interesting event. Now, that's just a brief example I like to use, but there's also ways to establish baselines of what is normal activity for your environment. So then you can start to understand what is abnormal activity. Now, again, Azure activity logs are kept with up to 90 days, and these contain all of the write actions, so post, puts, and deletes. Something a little different than AWS Cloudtrail, where with Cloudtrail's Trail, you can enable either read actions only, write actions only, or read and write. And the way that Azure Activity bundles these logs is through a correlation ID. So when, for example, I were to create a virtual machine within Azure, it'll show the first line item as Kyle started creation of virtual machine, and then anything else that had to deal with the creation of that virtual machine. And so if you could see here, when we create a deployment, you'll see it started, it was successful, or it was rejected. And so these are all bundled by that correlation ID for us. And the raw logs are going to be in JSON. So if we were bringing these logs to a logging tool or SIM, they're going to be easily parsed out of the box because a lot of these popular tools have a JSON parser for us. So we can search by key and value. Question here. Can we have access to the electronic copy of the slides that Kyle's presenting? Unfortunately, no. However, I do believe that this is being recorded. And at the end, Carol will mention where we can find the recording after it's all uploaded and such. Now, very similar to AWS SSM, again, another example of how these service providers are wanting to be good stewards to the consumers to provide out-of-the-box functionality. So we have within Azure Automation, their update manager, where we can update our Windows machines, install updates on a schedule. So that is something, again, to bring home the point of once we start deploying virtual machines out to our environments, we should have a strong understanding of how we are continuously updating and maintaining the running compute that we have in our environment, so it doesn't get away from us. And what I mean by get away from us is that depending on the connectivity to your virtual machines, you may have a virtual machine that's siloed out, that doesn't have any private IP connectivity, or you may have, say, a VPC that's just almost like an extension to your data center, where all of the resources are accessible over the private IP space. So strategizing and understanding how you're going to be adopting the cloud services is also going to be a paramount fact. So again, with Azure, they have the pen testing rules of engagement. I also will just drive home the fact that we should always review these documents, even though you may have done an assessment 100 times. If something were to be updated in that document and then all of a sudden our normal activity falls out of line, we want to make sure that we don't contribute to a problem. Now, Azure Advisor is a part of Azure Security Center, and it feeds recommendations for us, such as, does it have any high availability recommendations? Are there any security concerns at a high level? We could also then exclude resource groups. So maybe we have a development resource group that is kind of like, you know what, they can do what they want and as they please. But when it comes to our production resource groups, these need to be rank and file. What would be a best practice for security and logging in a multi-cloud scenario? I think I'll address that in actually a few slides. So When we get there, I'll call it out. And if it doesn't address your question, let me know, okay? So strategies. Again, these strategies aren't specific to a service provider. These can be adopted agnostically. Now, for a lot of environments, I came from an environment that did not have regulated requirements such as PCI or HIPAA or you name it. And so a great starting point is the Center for Internet Security Benchmarks. And these are great ways to start hardening your environments without potentially directly impacting productivity or existing applications. Now, with the CIS benchmarks, the Center for Internet Security has created benchmarks for AWS, for Azure, for Kubernetes, for Windows Server, for Red Hat Linux, and the list goes on and on. So these aren't benchmarks for just cloud service providers, but for pretty much a lot of the tools that were being used for production applications today. And so these are a great starting point. And if we look at an example of a CIS benchmark, you'll notice that there's a profile applicability at the top, and there's level 1 and level 2 profile applicabilities. Level 1 is you can introduce this benchmark without directly impacting a production workload. Now, I always recommend if you're going to be modifying stuff in a production environment, always have a rollback plan, because you don't want to be caught out in the middle of a lake without a paddle. So when it comes to the risk of introducing these benchmarks, it's relatively low. But I always err on the side of caution because I don't like being responsible for bringing down an environment. And so when you're implementing these controls, understand what it's doing and how it could potentially impact, or if it can. So for example, this benchmark is saying avoid the use of the root account. And that's a very fair benchmark to implement, because the root account is one of those accounts that should be created for, it's the first account that ever gets created. And then we should put multi-factor authentication on it and lock it away and only use it as a break glass in case of emergency, such as something is goofy and you need to log in as the root account for whatever reason. Very similar to how we don't run as administrator all the time on our workstations. I know some of you may be going, you know what, I do. That's fine. You like to live in the danger zone. I can respect that. But these benchmarks are great ways to start looking at how you can strategize your hardening practice. Now, the SANS incident response methodology is something that we should look at also, because your incident response is going to change when you move to the cloud. What are a couple ways that this can change? Well, it depends on if we're using infrastructure as a service, platform as a service, software as a service. How do we prepare for an incident? How do we identify that something went wrong? How can we contain the incident? What technologies are being used, and do we understand how we can contain those technologies? How can we verify that we eradicated the threat? Can we bring the systems back up without reintroducing the threat? And what were the lessons learned? And in the SANS reading room, there's actually a white paper, shameless plug, written by me on how to conduct an investigation in AWS. And I talk about the different considerations for each step of the SANS incident response methodology. And so I recommend taking a look at that just to understand what are the considerations when it comes to incident response. Because I guarantee you, when an incident does happen and we did not plan for a cloud-specific incident, there's going to be a lot of people running around with their hair on fire. And as hilarious as that may be to watch, it's not proactive and can ultimately introduce more impact and risk to our environment. So when it comes to a security and logging scenario, this can be applied to multiple service providers. So we have the cloud management plane, which is like Azure Activity Logs, AWS Cloudtrail. We have the service-specific logs. For example, if a service produces additional logging that it's doing, such as Azure functions or Azure apps, we can ingest those logs. Or another one is Azure Key Vault, the secret management service that they have. Another example is AWS's Elastic MapReduce that has additional logging that sends logs to S3, so we could consume those logs. Then you have your host and application logs. What is happening in our Linux servers or our Windows servers? How can we get those logs out? Well, if you're using some sort of like universal forwarder on-premise, or using an agent to send logs to a log collector, we could still do that in the cloud. If you don't have that existing capability, services like the CloudWatch log agent can get those logs from the host level out and to CloudWatch. And then from there, you can send it to a log analytic tool or create alerts and alarms within the CloudWatch log service itself. And then logs to storage systems. So this is logging activity and actions that's happening, say, on the simple storage service, also known as S3 or Azure storage. Having a fundamental understanding of, who's placing files, who's deleting files, who's accessing files from where and when can provide us additional insight. And then security system logs, such as, your vulnerability management, your endpoint detection and response tools. Maybe you have some other host-based technologies you're using, like a host-based IPS or a host-based IDS. Or this can also be, for example, a VPC traffic mirroring target that is doing some sort of network intelligence. And so bringing all of these in together are going to provide us insights to our environment. Now, usually when I'm sitting in front of a bunch of people and I say, you know what, tagging is awesome, a bunch of people kind of like, roll their eyes and go, really? And yeah, tagging is great. And the reason why I believe tagging is so great is because, one, it's free. Two, it allows us to use custom key pairs and values. So this can help us do cost management, automation. Some resources provide conditions to where we can do allows or denies based on the tag set of a resource. And a great way to think about how can tagging help us with automation. Well, for example, if we were to tag a virtual machine with the key of quarantine and the value of true, you may have some sort of automation that can then apply a security group to deny all outbound connectivity, to automatically create a snapshot or image, potentially share that image or snapshot with your security account, and then your security team can then do forensics on that snapshot while containing the virtual machine. And there's so many other steps to take for that to fully be implemented. But just spitballing from the hip, this is how we can leverage just something like tags. This can also help us create inventories of our environment, or if you use code names for your different data classification, you can tag resources that are processing that specific information. For example, if you have a fleet of servers that are processing PCI, you could tag them with that super secret code word. So you can, one, create inventories for those PCI systems. Two, you can understand if you're doing an incident response or just overall maintenance, that you can identify that this system takes care of PCI data. A couple things I always recommend is when you're doing tagging of resources, we should at least look to enforce tagging an owner. There's nothing worse than trying to figure out who owns what when an incident is happening, or if you need to notify someone that, their patching is out of date, or that there's something operationally wrong with their virtual machine, such as, operational intelligence is saying that it's, blue screening. I use blue screening with air quotes. A description, what's it being leveraged for? I mentioned classification of data already. One thing to consider, though, is not all resources support tagging. However, more and more resources do. So when you're coming up with this tagging strategy, understand where there could be a potential, I wouldn't say gap, but opportunity to understand that, okay, these resources cannot be tagged. However, from my experience, I'm seeing more and more resources being able to be tagged in the different service providers. And as a whole, here are the different types of security and logging services and what they're titled or named across the different types of cloud service providers. And with that, I thank everyone for your time. I hope you had fun. I had a great time. Feel free to reach out to us if you have questions. I'm available on Twitter. We have a Cloud Security Curriculum Alumni Slack channel if you've taken one of our classes before. And if you see me anywhere, feel free to say hello when we start traveling again. All right, everyone have a wonderful day.
All right, well, thank you so much, Kyle, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.